So good morning everyone. Today I am going to discuss about the computer organization subject. Computer organization subject. Coming to the introduction of this computer organization, we having some contents, that is computer types, functional units, basic operational concepts, bus structure. Coming to the computer types, what is mean by computer types? A computer can be defined as a fast electronic calculating machines that accepts the digitized input information, process it as per the list of internally stored instructions, and produces the resulting output information. It means what ma? So what are the computers we are using? That is a fast electronic computing device. That is a fast electronic computing device. Okay, now whatever the information it will take, that is in the digitized input information. That is a digitized input information. It can be processed the information that can be internally stored as per the instructions and produces the resulting output information that can be given to the user. So this is called the computer. So in this having the list of instructions called programs. In this we having list of instructions called programs, and internal storage is called computer memory. So in this we having different types of computers. So that is first personal computers. What is the use of personal computers? So this is mostly used in a common type found in, that is mostly found in homes, schools, businesses, offices, etc. So it is commonly used by everyone for their personal work. So these are the most common type of, this is a desktop computers with processing and storage units along with various and output devices. So next coming, this is called the personal computers. Next coming to notebook computers. What is meant by notebook computers? In the name itself we can understand it is size will be represented as a small notebook size. The notebook will be the laptop will be the computer will be located in a small notebook size. So it is a compatible and portable versions of PCs. Portable means we can carry from one place to the another, laptop, tabs, so they are mobiles. These are the portable computers. So this is acts as a version of PC, personal computers. This is called notebook computers. Next coming to workstations. What is meant by workstations? It having the high resolution input output graphics capability compared to the with the same dimensions of the desktop computers. So whatever the workstation, personal computers and notebook computers compared to these workstations have the high resolution input output graphics capability, but the dimension of this desktop computer is this workstation is the same as desktop computers. It is mainly used for engineering applications of interactive design work. This is called the workstations. Next coming to enterprise systems and mainframe computers. These are mainly used for business processing in medium to large corporations that requires much more computing power and storage capacity than workstations. Then workstations. So whatever we are saying, compared to the workstations, it having the high computing, more computing power and more storage capacity. The internet associated with the servers has become a dominant worldwide source of all the types of informations. So these are the four different types. Next, another type of computer is supercomputers. So what is the use of these supercomputers? These are mainly used for large scale numerical calculations required in applications like weather forecasting, aircraft design and simulations. So these are the 5 types of computers required here. So next coming to functional units. What is meant by functional units? A computer consists of 5 functionally independent main parts, that is input, memory, arithmetic logic unit, output and control unit. These are the 5 important units we are having in the functional units. Having the basic structure, this is the basic structure of the input, output, memory, arithmetic and logic and control. So this is the 5 functional units in the computer we are having. So next coming to the explanation of this input unit and output unit. So in this functional basic units we are having the input. What is mean by input? Input is nothing but it takes the information from the user. The input will be take the information from the user. Okay. So in this information taken by the system, and it will be stored in the memory. The information will be stored in the memory. So the input will be taken from by the user and through the keyboard. After that the information is stored in the memory. Okay na? The memory input device accepts the model. The input device accepts the input device. What will the use of input device? So the input device accepts the information as a source program, that is high level language. This is either stored in the memory or immediately used in the processor to perform desired operations. The program stored in the memory determines the processing steps. Basically, the computer converts the source program as to the object program into, it means machine language, and by using the compiler. So finally the result is sent to the outside world through the output device. These actions contained by the control unit. Next, coming to explanation of the input. What is meant by input unit? The high level language program, it is the high level language program that is coded data in a fed to a computer through input device. Keyboard is a most common type. Whenever a keyboard key is pressed, one corresponding word or number is translated in its equivalent binary code over a cable or fed either memory or processor. We use examples like microphones, joystick, trackball, mouse, scanner, etc. These are command at the input devices. Next, coming to memory unit. What is meant by memory unit? Memory unit is store the programs and data. It is basically contain two types, but is primary memory and secondary memory. So coming to the primary memory. So in the primary memory, we are exclusively associated with the processor and operates the electronic speeds. Programs must be stored in this memory while they are being executed. The memory contains a large number of semiconductor storage cells, each capable of storing 1 bit of information. These are processed in a group of fixed size called word. To provide a easy access to a word in memory, a distinct addresses of associated with each word locations. Addresses are numbers that identify the memory locations. The number of bits in each word is called word length of a computer. The programs must be reside in memory during the execution. Instructions and data can be written into the memory and read out under the control of processor. So in this cache are called small fast RAM units, so which are coupled with the processor and often contained on the same IC chip to achieve high performance. The primary storage is essentially tends to be expansive. Next, coming to, this is called the primary memory. Next, coming to secondary memory. So it is used where large amount of data and programs have to be stored, particularly informations that access to infrequently. Examples are magnetic disks, tapes, optical disks, CD-ROMs, flash drives. These are the examples of the secondary memory. Next, coming to arithmetic logic unit. What is the use of arithmetic logic unit? So computer operations are executed in ALU of the processor. So like addition, subtraction, division, multiplication, etc. So the operands are brought into the ALU from memory and stored in high-speed storage elements called registers. According to the instructions, the operations is transformed in the required sequence. The control and ALU are many times faster than other devices that connected to the computer system. A single processor to control a number of external devices such as keyboards, displays, magnetic and optical disks, sensors, and other mechanical controllers. This is called the arithmetic logic unit. Next, coming to output unit. This is the counterpart of input unit. Its basic function is to be sent to the processor results of the outside the world. So examples are printer, speaker, monitor are called the input-output units, as the provided both input and output functionalities. Next, coming to control unit. What is meant by control unit? So control unit is nothing but it is effectively is a nerve center that sends the signals to the other units and sends their states. The actual timing signals that govern the transfer of data between input unit, processor, memory and output unit are generated by the control unit. This is called the control unit. Next, coming to basic operational concepts. What is meant by basic operational concepts? So it performs the given task. An appropriate program consisting of a list of instructions is stored. It is stored in the memory. Individual instructions are brought from the memory into the processor, which executes the specified operations. Data to be used as a operands are also stored in the memory. Examples are add location R0. Add location R0. So the instructions add location means what, ma? This is the operation. Add is an operation. LOC is a location, memory location, and this R0 is a register. Okay, the instruction adds the operands at memory location lock A to operand in register R0 and place the sum into register. This instruction requires the performance of several steps. First, the instruction is to be fetched from the memory into the processor. The operands at location A is fetched and added to the content of register R0. Finally, the result of sum is stored in the register R0. So, in the sum of other types of computers, these two types of operations are performed by separate instructions for performance reasons. Load is another operation that is location A R1. So, we are loading the data in the register R1 after adding the R1 and R0. Transfer between the memory and the processor are started by sending the address of the memory location to be accessed to the memory unit and issuing the appropriate control signals. The data are then transformed to or from the memory. So this is the basic operational concepts. Next, I am having a small diagram here. This is the diagram of the connection between processor and the memory. Here in the diagram, the memory and processor are connected with each other. So in this, we are using the we are having different instructions we are following here. The memory and processor can be connected, and addition to the ALU and control circuitry, the processor contains a number of registers used for several different purposes. In this, we are having different instruction, things, that is instruction registers, IR, and PC is a program counter, and MAR is a memory address register, MDR is a memory data register. These are the things we are having to control between the memory and the processor. What is meant by instruction register? It holds the instructions that is currently being executed. Its output is available for the control circuits, which generates the timing signals that control the various processing elements in one execution of instructions. That is called the instruction register. Next, coming to program counter. What is meant by program counter? This is another specialized register that keeps track of execution of a program. It contains the memory address of the next instructions to be fetched and executed. So besides IR and PC, there are n general purpose registers R0 through or n-1 or n-1 we are having. Next, another two registers we are having for communication with memory, that is MAR and MDR. What is meant by MAR? MAR means memory address register. It holds the address of the location to be accessed. MDR is called, it contains the data which written or into the read out of the address location. So these are the instructions we are following in this. Some operating steps we are following in this to execute this to perform the operation between memory and processor. Program resides in the memory and usually get their input unit. The execution of the program starts when the PC is set to point at the first instruction of the program. Instructions of the program. The content of PC transformed to MAR and read the control signal is sent to the memory. After the time required to access the memory elapses, the address word is read out of the memory and loaded into the MDR. Now content of MDR are transferred to the IR, and now instruction is ready to be decoded and executed. If the instruction involves on operations by the ALU, it is necessary to obtain the required operands. An operand in the memory is to fetched and sending the address to MAR and initiate the read cycle. Okay, next we are having the next step. When operand has been read from the memory to the MDR, it is transferred from MDR to ALU. Okay, next one or two such repeated cycles, the ALU can be performed desired operations. If the result of this operation is to be stored in the memory, the result is sent to the MDR. The address of the location where the result is stored in is sent to the MAR and write in the cycle is initiated. Next, the content of PC are incremented, so the PC points to the next instruction that is to be executed. So these are the different operating steps we are going to follow. Okay. So next, coming to the bus structure. What is mean by bus structure? These are the different points. Next, coming to the bus structure. So the simplest and most common way of interconnecting various parts of the computer is to use a single bus. To achieve a reasonable speed of operation, a computer must be organized so that all its units can be handled one full word of the data at a given time. A group of lines that serves as a connecting ports for several devices is called a bus. So in addition to lines that carry the data, the bus must be have lines for address and control purposes. So we are using a simple way to interconnect is to use a simple bus as shown in the figure. I am having a small figure of the bus structure. This is the bus structure. In this bus structure, we are using the single bus structure. So whatever the connection devices we are having, we are connected in a single bus. Input, output, memory, processor, these are connected in a single bus line, straight line. Okay, na? So since the bus can be used for only one transfer at a time, only two units are actively use the bus at any given time. Bus controls lines are used or arbitrary multiple request for use of one bus. So we are having the single bus structure that is low cost, very flexible for attaching the peripheral devices. So multiple bus structures certainly increases the performance, but also increases the cost significantly. All the interconnected devices are not of same speed and time, leads to bit of a program. Okay, bit of the problem. So we can solve by using a catch register, that is buffer register. These buffer registers are electronic registers of small capacity and compared to main memory, but of comparable speed. So the instructions from the processor at once are loaded into their buffers and then complete transfer of data at fast rate will take place. So this is called the bus structure. Next, coming to software. So the computer must already contain some system software to enter and run the application programs. Systems software is a collection of programs that are executed as needed to perform functions such as receiving and interrupting user commands, entering and editing application programs and storing them as a files, secondary storage devices, managing the storage and retrieval of files in secondary storage devices, running standard application programs such as word processor, spreadsheet, presentation, games with data supplied by the user, controlling input-output units by receiving input information and produce output results, translating programs from source prepared by the user into object from consisting of machine instruction, linking and running standard applications programs with existing standards libraries, okay, such as numerical computation packages. So these are the different instruction functions we are performing in the software. So what is operating system software? What is operating system software? The operating system software system is a collection of routines that is used to control the sharing of and interacting among various computer units. So as they execute application programs, The operating system routine perform the task required to assign computer resources to individual application programs. These tasks include assigning memory and magnetic disks space to program and data files, moving data between memory and disk units, and handling input output operations. So let us consider a system with one processor, one disk and one printer. Assume that part of a program's task involves reading a data file from a disk into the memory and performing some computations on data and printing the result. A convenient way to sharing the processor time is by timeline diagram. So coming to this next slide, this is the performance. Next, coming to performance, the most important measure of performance of a computer is to execute a program. The speed with which a computer executes program is affected by the design of its hardware. Best performance, it is necessary to design a compiles the machine instruction set and the hardware it is coordinated way. The total time required to execute the program is called elapsed time, which measures the performance of the entire computer. It is affected the speed of the processor, the disk and the printer. The time needed to execute an instruction is called the processor time. So this is the processor with cache memory. So we following the program instructions and data between the memory and the processor starts of execution. All program instructions and the data are stored in the main memory. The execution proceeds instructions are fetched one by one over the bus into the processor and copy placed in a cache later. Same instructions or data item read to second time. So it is directly from the cache. It read directly from the cache. The processor having the small cache memory to be fabricated on a single IC chip. The internal speed of the performing basic steps instruction processing on chip is very high and considerably faster than the speed. The instructions and data can be fetched from the main memory. The program will be executed faster if the movement of the instruction and data between main memory and the processor is minimized, which is achieved using the cache. So we are having the example. Suppose a number of instructions are executed repeatedly over a short period of time, as happens in a program loop. If the instructions are available in the cache, they can be fetched quickly during the period of repeated use. The same applies to the data that are used repeatedly. So this is the performance. So next, basic operation performance equations. We need to focus on attention on the processor time component of the total elapsed time. Let T be the processor time required to execute a program that has been prepared in some high level language. The compiler generates the machine language object program that corresponds to the source program. Assume that complete execution of a program requires a execution of n machine cycle languages instructions. The number n is the actual number of instruction execution, and it is necessarily equal to the number of machine cycle instructions in the object program. Some instructions may be executed more than once. In case of instruction inside the program loop, others may not be executed depending on the input data used. Suppose the average number of basic steps needed to execute one machine cycle instruction is S, where each basic step is completed in one clock cycle. If one clock rate is R cycle per second, the program execution time is given by T is equal to N into, this is the example, T is equal to N into S by R. Okay, N into S by R. Okay, so here where must the N, S, R are not independent parameters. Changing one may affect another. Introducing a new feature in the design of processor will lead to improve the performance only if all result is reduces the value of T. Pipelining and superscalar operations. Next, so we assume the instructions are executed one after another. The value of S is the total number of basic steps or clock cycle required to execute one instructions. A Substantial improvement in the performance can be achieved by overlapping the execution of successive instruction using a required technique called pipelining. Consider a add, this is the example, consider add R1, R2, R3, okay, and we are adding the content of R1 and R2 and placing the sum into R3. So the content of R1 and R2 first transferred to the input of ALU. After addition operation is performed, the sum is transferred to R3. The processor can be read the next instructions from the memory. While the addition operation is being transformed, the instructions also uses ALU is operand. The ALU, its operand can be transformed to the ALU input. At the same time that the add instruction is being transformed to R3. So we are R3. So this like the communication will be addition operations will be occurred. So the higher degree of accuracy is achieved to multiple instructions pipelines are implemented in the processor. This means multiple functional units are used for creating the parallel paths through which different instructions can be executed in parallel with such agreement. Okay, so the its clock cycle. So this mode of operations is called superscalar execution. So S can be reduced to less than 1, but the parallel execution must be preserve logical correctness of programs. That result produced must be same to produced by serial execution of a program instructions. Nowadays, many processors are designed in this manner. Next, coming to clock rate. So these are two possibilities for increasing the clock rate. So improving the IC technology makes logical circuit faster, which reduces the time of execution of basic steps. This allows the clock period P to be reduce the clock rate R to be increased. Reducing the amount of processing done in one basic step also makes it possible to reduce a clock period P. If the action that have been performed by an instructions remain the same, the number of basic steps needed by may increases. So this is the clock rate. Next, coming to instructions of CISC and RISC. So what is meant by CISC? A simple instruction requires a small number of basic steps and executes complex instructions involves a large number of steps. For a processor that has only simple instructions, a large number of instructions may be needed to perform a given programming task. A large value of n and small value of s, on other hand, if individual instructions perform more complex operations, a fewer instructions will be needed. The lower value of n and large value of s. So it is not obvious if one choice is better than other. So but the complex instructions combined with pipelines would achieve one best performance. It must be easier to implement the efficient pipelining in processors with simple instruction steps. Next, coming to performance measurement. So it is very important. We have able to access the performance of a computer designers use performance estimates to evaluate the effectiveness of future. It provides the arguments suggest that performance of a computer is given by the execution time t for a program of interest. In spite of performance equation being so simple, the evaluation of t is highly complex. The parameters like clock speed and various architectural features are not reliable indicator of the expected performance. The measurements of computer performance using benchmark programs is done make comparison possible. Standardized programs must be used. So in these benchmark programs, synthetic programs not properly predict the performance obtained which real application programs are run. So this is called the performance measurements. So we are having a small formula. This is SPC rating computed as SPC rating is equal to running time on the reference computer by running time on the computer under test. So this means that the computer under text is 50 times as fast as the Ultra Spark 10. This repeated for all the programs in the SPC suite and the geometric mean the result is completed. Okay. SPC means System Performance Evaluation Corporation. Evaluation Corporation. So that is the full form of SPC. Okay, the SPCI rating program I is suit. The overall SPC rating for the computer is given by. So these are the performance. Okay, next multi-processor and multi-computer. So what is mean by multi-processor and multi-computer? So it contains the large computers that contains a number of processor units are called multi-processor system. Okay, these systems either executes a number of different applications task in parallel and execute subtasks in a single large tasks in parallel. All processors usually have all processors usually have access all the memory locations in such systems. Hence, they are called a shared memory multiprocessor systems. High performance of these systems comes with much increased complexity and cost. So, the contrast the multiprocessor systems, it also possible to use an interconnected group of complete computers to achieve high total computational power. These computers normally have to access their own memory units. When the task they are executing need to communicate data, they do so by exchanging messages over a communication network. This properly distinguishes them from shared memory multiprocessor lead to name message passing multi-computer. So this is called the multiprocessor and multi-computer. So next coming to data types. What is mean by data types? So data types. In data types we are having, so coming to data types. Data types are used in digital computers. What is mean by data type? Data types is mainly used in digital computers, can be classified into three types. They are numbers, letters and discrete symbols. Coming to the number system. What is mean by number system? In the number systems we are having radix. A number system of base or radix or is a system that uses distinct symbols, for a or digits. Numbers are represented by string of a digit symbol. So that is called the radix. Next coming to decimal. The decimal number system in every day we used to employ the radix 10 symbols. The 10 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The string of digits, that is 724.5, is interpreted to represent the quality. 7 into 10 square plus 2 into 10 power 1 plus 4 into 10 power 0 plus 5 into 10 power minus. This is the representation of the digits of the 724.5. So this is the example. Okay, next coming to the binary. So binary numbers is what, which is understood by the computer. So the binary number system uses the radix 2. The two digit symbols used are 0 and 1. The string of digits that is represented, how we are representing a string of digits? 1 0 1 1 0 1. It is interpreted by to represents the quality, that is 1 into 2 power 5 in the binary system. 1 into 2 power 5, binary is what? 2. 1 into 2 power 5 plus, so from back to 2 power 0, 1 into 2 power 0 plus 0 into 2 power 1. By this is 1 0 1 1 0 ki mana ila represent chestam. Ee binary form loki represent chestam. Okay, 2 power 0, 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power q plus 0 into 2 power 4 plus 1 into 2 power 5. This is the representation of the binary. Next coming to the octahexadecimal. So octahexadecimal ante enti? In the name itself we can understand. Beside the decimal and binary number systems, the octal is represented as 8 and hexadecimal radix is 16. They are important in digital computer work. The 8 symbol of the octal systems are 0, 1, 2, 3, 4, 5, 6, 7. The 16 symbols of the hexadecimal systems are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, these are the hexadecimal representation symbols. So example or 736 I am taking 0.4. Octadecimal, 7 into 8 square plus 3 into 8 power 1 plus 6 into 8 power 0 plus 4 into 8 power minus 1. So this can be represented this like 478.5 base 10. This is the representation of the octal. Okay, next this is the main example. So 1 to 7543 తీసుకున్నాను. ఇది వచ్చి ఆక్టల్ డెసిమల్ రిప్రజెంటేషన్. ఇక్కడ మనం 1 అనేది ఇలా రిప్రజెంట్ చేసామా. సో 1 అనేది 2 అనేది బైనరీ ఫామ్లో రిప్రజెంట్ చేసాం. సో ఈ బైనరీ ఫామ్లో రిప్రజెంట్ చేసిన దాన్ని హెక్సాడెసిమల్లోకి కన్వర్ట్ చేయాలి. సో బైనరీ అంటే 3 వాల్యూస్ ఉంటాయి మనకి, హెక్సాడెసిమల్లో 4 ఉంటాయి, 8421. ఇక్కడ వచ్చి 421 అంతే. ఓకేనా, అలా రిప్రజెంట్ చేసాం. హెక్సాడెసిమల్ టు ఆక్టల్ టు హెక్సాడెసిమల్, ఆక్టల్ నుంచి బైనరీకి, బైనరీ నుంచి హెక్సాడెసిమల్కి కన్వర్ట్ చేసాం. సో ద కన్వర్షన్ ఆఫ్ from to binary, octal and hexadecimal representation plays an important part in digital computer, since 2 cube is equal to 8 and 2 power 4 is equal to 16. Each octal digital corresponds to the 3 binary digits and each hexadecimal digit corresponds to 4 binary digits. The conversion from binary to octal is easily accomplished by partitioning the binary number into groups or 3 bits. Each the corresponding octal bit is then assigned to each group of bits and the string of digits. So obtained gives octal equivalent of the binary number. So this is the representation of this. So I have, so okay na. So in this we are representing the octal to binary, binary to hexadecimal. So this is the conversion from binary to hexadecimal is similar, except that bits are divided into groups of 4 and corresponding hexadecimal digits for each group of 4 bits. So I told no, first octal అనేది మనకి ఇలా ఉంటుంది. octal 8 వాల్యూస్ octal అంటే 8 అమ్మా. సో దాంట్లో 8లో నుంచి ఆక్టల్ డెసిమల్లో ఉన్న వాల్యూస్ని బైనరీలోకి కన్వర్ట్ చేస్తాం. బైనరీలో నుంచి హెక్సాడెసిమల్ వాల్యూ ఎంతమ్మా 4 అనమాట. 4లోకి 4 వాల్యూస్ తీసుకున్నాం. 1010 1111 0110 0011 ఇలా 4 కంబైన్ చేసి మనం దాని యొక్క రిప్రజెంటేషన్ అనేది జరుగుతుంది. ఓకేనా. నెక్స్ట్ డేటా రిప్రజెంటేషన్. నెక్స్ట్ కమింగ్ టు data decimal representation. So decimal all input decimal numbers are concerned with binary numbers. The computer perform all arithmetic operations in binary and then convert the binary result back to decimal. Decimal types. Decimal number entered the computer usually as binary coded alphanumerical characters. When decimal numbers are used for internal arithmetic computations, they are converted to a binary code with 4 bits per digit. A binary code is a group of n bits that assume up to 2 power n distinct combinations of ones and zeros, with each combination representing one element of the set that being coded. A set of 8 element requires a 3-bit code, a set of 16 element requires a 4-bit code, and so on. So the bit assignment most commonly used for the decimal digits is the straight binary assignment listed in the first 10 entries of table. This particular code is called binary coded decimal and is commonly referred to as abbreviation BCD. Okay, so next coming to alphanumerical representation. In alphanumerical character set is a set of elements that includes the 10 decimal digits and 26 letters of alphabet and a numbers of special characters such as $, plus and equals. The standard alphanumerical binary code is ASCII. ASCII means full form American Standard Code of Information Interchange. So this is which uses for 7 bits of coded 128 characters. The binary code for the uppercase letters, the decimal bits and the fewer special characters is listed in this table. So binary code plays a important role for part of digital computer operations. These codes, the code must be binary because register can only hold binary information. So this is called the alphanumerical representation. This is called alphanumeric representation. Okay, next this is called alphanumeric representation. Okay ma, so up to here we have discussed about the alphanumerical representation. So, okay, ma'am. Thank you for listening and giving this opportunity. Thank you.